have learned the theory behind the 5W framework. You have seen how it systematically organizes geographic data. Now it is time to actively practice it. I want you to apply this single framework to 3 distinct real-world problems spanning 3 different continents. First, a utility company in the United States needs to prioritize which power lines to upgrade before hurricane season. Where do you start? Second, a coffee chain wants to open 5 new stores in Cairo, Egypt. How do you decide the exact locations? Third, a government agency in Bangladesh needs to identify the specific communities most vulnerable to monsoon flooding. How do you prioritize them? These 3 scenarios represent vastly different scales, industries, and geographic contexts. However, the spatial logic required to solve them remains the same. To begin, look at these 2 documents. You will need to download the blank exercise worksheet and the 5W framework PDF from your course dashboard. This grid is your starting point. Step 1 is to fill in the who, what, where, why, and when for each scenario. If you end up with an empty box, that signals a valuable data gap you must resolve before analysis begins. Step 2 is decomposition. You will break the main problem into 3 or more specific, answerable spatial sub-questions. Your success criteria for this step is clarity. Another analyst must be able to read your sub-questions and immediately understand what needs to be mapped without having to ask you for clarification. Step 3 is methodology. For each generated sub-question, you need to identify a specific spatial analysis type, such as proximity, overlay, or pattern detection. A best guess on the analysis type is perfectly fine right now. We will cover these specific techniques in depth in Module 3. Look at the instruction on screen. I want you to pause this video, set a timer for 10 minutes, and physically complete the worksheet. Taking this manual pause breaks the habit of passive consumption. It forces the mental transition from abstract theory to practical analytical skill. I will be here when you get back. Welcome back. The effort you just put into that practical work is exactly how you build this skill. Let's review your foundation. Segment 1.2 showed that critical answers are geographic. 1.3 gave you the 5W framework. 1.4 transformed a vague request into an analytical plan. 1.5 proved questions control insights. And 1.6 showed AI makes spatial thinking increasingly valuable. Mastering these specific conceptual steps ensures you have the underlying logic required to make any complex dataset or future software tool useful. As this slide indicates, we treat spatial thinking as separate from software proficiency. This logic functions as a mental model for viewing the world. The same principle applies to automation. Artificial intelligence processes data, but it requires human spatial strategy to yield a useful result. This visualization shows where we are heading next. Having covered how to ask the right questions, Module 2 transitions to evaluating spatial data. We will cover specific technical topics, including the difference between vector and raster formats, the hidden dangers of map projections, and how to perform rapid metadata analysis. Module 1 taught you how to frame the problem. Module 2 will teach you how to judge if the available data is capable of answering it. You can sign up for the free Module 2 waitlist using the link provided in the description below. Please retain your downloaded PDFs and worksheets. They are tools meant to be used on your future projects. You have completed Module 1. By learning to decompose these problems, you have built the foundational logic needed to identify geographic insights in your own work. You have completed Module 1 and learned how to frame the problem. Module 2 will teach you how to evaluate the data. Stay tuned for the next module as we build the skills to critically judge your data before it ever hits the software.